Rotarians and guests, it's now my great pleasure to introduce today's guest speaker, Adrian Jones. Adrian is a civil and structural engineer by training, as you might imagine from the subject of today's talk. He joined the firm of Conor Wagner about 30 years ago as a Royal graduate. I remember it very well. I was leading the company in this region at that time, and we quickly recognised a star in the making. He was a very bright, very assiduous young engineer, and went on, as you will have read from the notes, to do great things. I'm not sure that he thought I was such a good boss, though. In the first year, within a few months of joining, we had a staff golf day up at Ashbourne, and he went within an ace of killing me with his tee shot on the fifth tee.
Sorry.
He swears that it was just a mistimed tee shot, but I'm not so sure. Anyway, Adrian went on to do a number of buildings in Adelaide, which you would all recognise: the David Jones building, the RAA building named Light Square, the building that now replaces the old Appetizer building on the corner of Waymark and King William, and the larger building behind that, the law courts at the the southern end of Victoria Square, and others. And having done that, he was appointed to lead the structural team of the firm in Dubai, which is of course where he undertook the project that we're about to hear about. In 2017, he and his wife Tracy and their two boys relocated to Adelaide, and he now is regional manager, South Australia, Western Australia, Northern Territory for the firm of Mott McDonald. And by the way, some of you may have come across or heard of Adrian's wife Tracy. She is a very accomplished writer, performer and comedian. She's performed at fringes and festivals and so on. So without further ado, Rotarians and guests, I give you Adrian Jones.
Thank you, Chris, and I will hasten to add that it was just my normal slice that whizzed past your ears on that day. Thank you for having me. I must say, in my early career, or in fact for the first 15 or 20 years, Chris provided outstanding leadership to me and modelled the things that I have aspired to model myself throughout my career. So thank you for inviting me today, Chris, and all of you. Is that audio coming through okay toward the back? I'll try to keep this as close as possible. I will give you a bit of an overview of a project that I'm very proud of and humbled to be involved with during my time in the Middle East. The project was called The Tower Dubai, for a developer by the name of EMAR, who is effectively the government developer in Dubai. It's a significant building. It will be, when completed, the tallest building in the world by quite some distance. I'll go on to say a bit more about that in a moment. Firstly, I'd like to acknowledge the primary designer of this building. It's Santiago Calatrava. Some of you may be familiar with his name and his work. He's possibly the preeminent architect engineer in the world at present, and has been involved in many significant commissions around the world, including the new work on the site of the demolished Twin Towers in New York. The other people I'd like to acknowledge is my family. Of course, none of these things really happens alone, and my wife and children were very kind to give me the time and space and support to take on a project of this size, which required quite a bit of sacrifice on their part. So I would like to acknowledge them in this. So very tall projects, very substantial and buildings of serious height are always shrouded in mystery. There is a lot of propaganda and untruths about any tall building. So much so that I won't tell you the exact height of this building, rather talk around approximate numbers, because I've signed certain documents which say I must not. But throughout projects like this, there is a lot of untruths said, because of course nobody wants other people to know actually how tall your building is going to be, because of course they'll go 1 metre higher. So we had a complete ban on social media. We had a complete ban on discussing the project in any way throughout the 2 years that I was involved. I'm not sure, some of you may know the Middle East market and the Dubai market to some degree. It's a very unusual place. They do not subscribe to the normal principles of supply and demand economics. They build it and assume that you will come. So this is not about a demand-driven thing. This is about building an icon and assuming or knowing that people will flock to be associated with that, either live next to it, work in it, create a business around it. This is a photo that I took standing in the centre of my site, the tower site, looking back towards the current tallest building in the world, Burj Khalifa, which is 824 metres high. The tower, the precinct in the bottom of the photograph here is currently literally brown desert. There is nothing there at present other than the foundations of the tower. All of the things that you see in front of you will be developed over the next 10 years to be something like the image you can see in the background, which is the current downtown area of Dubai, which has grown up around Burj Khalifa. So EMAR is taking a very well established principle of build an icon and develop around it, and they're doing the same again, only bigger and better. And there are some interesting stats around building developments like this. So what EMAR has learned from the first development is that the property around the icon is generally valued at about 30 to 40% greater capital value than if you had placed the same asset somewhere else. So the presence of the icon creates another 40% value, roughly, immediately. And of course that adds enormous value to their development. The tower is worth, give or take, 2.5 billion US. The area of the development around the tower is something like 100,000 square metres, no sorry, that's not right, 10 million square metres of development. So when you do the maths, the extra over value created by developing around an icon is well in excess of 20 billion US, well in excess, which is just the differential. So the 20 billion extra over easily pays for the 2.5 billion without even taking into account the revenue generated by the facility itself. So to go up to the observation deck in the tower will cost you, depending on how late you book it, somewhere between 100 and 200 Australian, but it will be well worth it. This is the precinct in plan view. So the tower sits at the centre of a disc.
So if you hold the microphone straight in.
Is that better? Thank you. The tower sits at the centre of a 500-metre diameter disc of landscaping, water features, and of course built form. In terms of height, I will say it's in the vicinity of 1.2 kilometres high, which is almost half as big again as the Burj Khalifa currently is. The equivalent number of stories is something like 400 stories of a traditional building, 300 to 400 stories. The bottom section is known as the core. The occupiable section, the bud, you probably can't quite read that, and then there is a spire on top, as is normal on these buildings. The main public observation deck is at about 900 metres above the ground, and the VVIP observation deck is at 1,001 metres, perhaps for obvious reasons. So you would have to be royalty to get up to that deck, and it's a very special space. But there is nothing else that the developer is willing to divulge up there than observation decks. There is a lot of plant and equipment, there's a lot of safety spaces and plant and so on, lift houses and the like. And there are 2 floors up there. The bud section is around about the equivalent of a 50-storey building. And there are 2 floors up there that are unallocated. I suspect that will be a penthouse for the royal family. This is a bit of a complicated diagram. The point I wanted to make is about the sculptural work done by Calatrava in creating the form of this structure. There are 208 cables that support the tower. So the tower is a bit like a lollipop in a way. It has a very thin shaft, and then it has a larger section on top, and it has 208 steel cables holding it up. It's a bit like a suspension bridge, but vertical. And those cables, as I've tried to show in red, are placed actually not to make it more stable, but completely due to aesthetic desires. So Calatrava actually placed all of these cables to look like a harpsichord that had been bent out of shape, and secondarily so that images could be projected onto the array of cables, so that standing about a kilometre away you would be able to watch a movie on the cable array, and I'll show you something about that later. So there are 208 cables that hold this thing up. The biggest one is 450 millimetres diameter, so about like that. Very large pieces of steelwork. The core section is 27 metres in diameter, and the shell, the concrete shell which that is made from, is 4 metres thick all the way around. So it's like a very large donut, or a donut stack, if you like. At the base of the tower, obviously there's beautiful landscaping and water features, but the water features serve more than just a visual purpose. The water features are actually there as a security measure. You could imagine that this thing might be the target of terrorist attacks. It will be a very visible asset in the Middle East, which can be volatile from time to time. And one of the ways to protect structures like this is actually to make it impossible to get to the supporting components. So actually, the water, or the water protection is of a size and disposition such that you actually can't drive a truck or a car anywhere near the base of the supporting cables. We actually analysed the tower so that any 3 of the 208 cables could be removed or damaged at any one time, and the structure would still be stable. That was as a result of the security assessments that were done. At the base of the, sorry, you may not all be able to see it, at the base of the tower there's an enormous concourse. So there's a 500 metre diameter, 30 metre high concourse underneath the tower plaza, which is filled with botanical gardens, reception, entry and exit to the tower, retail, food and bev, all of the things that you would expect to see in Dubai. This is an image of that arrival space. This is very Calatrava-esque, if any of you know Calatrava's work. It's a very exposed, beautiful structure. Calatrava, more than a preeminent architect and engineer, is an artist and sculptor. He creates actually sculpture, in my view, rather than just buildings. These are the Botanic Gardens. This is about a 30 metre high space. This is the public, or an image of the public observation deck. So this is up at 900 metres in the air. You can see Burj Khalifa in the background. It's about 8 kilometres away as the crow flies. But that's a 35 metre high space, shrouded completely in in an Arabic mushrab, which is the traditional Arabic shroud. In terms of lifts, getting up to the top of the tower takes some time. It takes about 2.5 minutes. We actually could have done it in 1.5 minutes, but the client said, no, actually I want it to take longer. Up in the top right-hand corner, I've tried to show each lift has a full, is a 360-degree media environment. So you have constant videos going along, and EMA wanted to have 2.5 minutes for tourists to be able to see the full story of Dubai over that period of time. 1.5 minutes wasn't quite going to be long enough. So they actually asked us to slow the lifts down so that their patrons could have a little bit more time. There are 8 primary lifts in the core of the building, so that takes you up to about 900 metres. You then transition to separate lifts which then go to the outside of the bud area, so they're glass lifts that track you up to the observation deck, and you can, that's where you start to enjoy the view. Now this is really frightening. I'm not sure that if you've got a weak heart, this is not for you, but for an extra fee, you can see on the right-hand side, you can enjoy an experience of being on a rotating balcony. So you can enter the balcony inside the building and it will rotate to take you outside the building envelope. What might not be immediately obvious is that you're in a complete glass shell. So you're standing on a glass floor, glass in front of you, and actually no lid on top of you. So you would be 900 metres in the air, able to see straight down through your feet. So better than any theme park ride that I can think of. I wanted to show you some of the beautiful sculptural sketches and watercolors that Santiago Calatrava produces. The way he works is he produced the sketch on the left, which is the rotating balcony sketch. That's actually 3 views of the rotating balcony. It's a plan, a cross-section and an elevation, all in one. He thinks always in 3 dimensions. He sketches, paints it in a beautiful watercolour, and then his team translates his artwork into drawings and specifications that can be built. It's really quite an amazing process. The sketch on the left is worth around about $2,500 US. He's got his son, Mikhail, who I work with very closely, tells me that he has some 100,000 sketches of a similar type. When his father retires, he has no intention to carry on the business. He doesn't need to. He can just sell a couple of sketches every week. This is the light feature that I mentioned earlier, similar to what does happen on other very tall buildings around the world. Light shows, movies, animations can be projected onto the cable array. So it's perhaps not brilliantly shown, but on the top left is this tower, some of the other buildings, Burj Khalifa and Eiffel Tower and so on, that have similar things. So actually, the entertainment value or the projection of light onto this, the tower building, was an enormously important part of getting the design right. Obviously, in an emergency, being able to get out of the building is also enormously important, but you're a long way up. There are a number of refuge floors at the top, so if there's a fire or some kind of emergency, you can take refuge, but eventually you've got to come down. We did a number of studies on this because clearly that's a difficult thing to do. Unfortunately, we estimate it will take, depending on your fitness, between 2 and 6 hours to descend down through the 5 stairs in the core. I suspect some people having to do that might not ever make it. I wanted to talk a little bit about wind effects at the top of the tower. We spent a lot of time, as you might imagine, trying to model the way this tower would respond to the various wind effects. And a lot of that is not only due to its height, but it's about how you apply and detail the cladding around the structure so that it effectively mitigates the wind effects rather than escalating them. On the left, we started with a porous shroud option that went entirely around the core structure to try to mitigate wind. That didn't work. We went to, so Santiago Calatrava wanted these protrusions, the blue lumps, because it created it's supposed to emulate the veins on a flower, on the stem of a flower. He was trying to kind of show that in his architecture. So we had to deal with these protrusions somehow or other. So we tried to make them porous, which wasn't enough. Because we were getting, you may have heard of the term vortex shedding. It creates, you get a response from the structure perpendicular to the direction of the wind because of the wind kind of bumping into pieces of the structure, effectively. So on the right-hand side, what we ended up doing was taking the protrusions and pulling them away from the core to create a gap in behind. So I'm not sure if you can see the image at the bottom. Without the gap behind the protrusion, the wind bumps into the protrusion and pushes off to the side, which creates the sideways movement in the structure. On the right-hand side, if you allow wind to go through the gap, the wind that goes around the outside actually then wants to reattach itself to the airflow that goes straight through. And that reattachment makes an enormous difference to the response of a really tall structure. So, you know, we spent probably 6 months working out how to make this work. But, and of course it was in, we had a whole lot of wind tunnel modelling and so on going on as well. The response of the structure to wind, obviously, is key. The natural frequency of response varies depending on which mode of response. There are many modes. The higher up the number of modes, the less impact they have. But usually the first 8 to 10 modes are key. The mode 1 is a simple, a traditional cantilever mode, which you might expect to happen, and it does. That happens first. But what happens in mode 3 and mode 7 is shown across the page. The spire starts whipping, and it starts to have a disproportionate effect on the structure. And in mode 7, it's like the tail wagging the dog. What actually happens is the spire starts whipping to such an extent that it drives that whipping motion down through the tower and creates the forces that are unmanageable. So we had to use a combination of liquid dampers and mass dampers at each of those node points. We had 5 in the end in order to damp that motion, particularly the higher mode effects. In terms of foundations, you can imagine the foundations are pretty substantial. In fact, they're built, if you want to go and have a look at them, they're not that spectacular, unless you're a structural engineer. There are 145 barrette piles underneath the core of the structure. Each of the barrette piles is 2.8 metres by 1.8 metres, so it's a rectangle about the size of 2 of these tables put together. And they're driven, or not driven, they're poured down to 80 metres below ground. So we have this enormous concrete needles going down to the limestone structures deep below the sand. I'll talk a little bit in a moment about the cable, how we hold down the cables at the perimeter of the building. We were desperate actually to make sure we had more than one way to hold this structure down, because as you can imagine, the way this structure pitches and moves, it's like being on the QE2. It can roll the way you would sense the motion, and this is motion that is at the top about 8 metres in each direction during a serviceability wind speed. So this can happen at any time. It can go up to 12 metres each way. at the top in the ultimate wind event. It's not so much the amount that the tower moves that you feel, it's about the acceleration, the way it moves at the top, or the acceleration is the key thing that we perceive when we perceive motion. So actually, surprisingly, 8 metres in each direction is not that bad. But of course, to limit that, the cables had to have, the support cables had to have a certain amount of tension, and we had to hold that down at the perimeter. In the end, rather than just using deep piles to hold it down, we also provided simply enough maps. We used actually a very simple notion of Kentledge to hold down, provide enough dead weight so that if everything else failed, there was still enough dead weight to hold the cables in position. Now, at the base of each cable is an enormous cable structure that is 17 metres deep. So this is about 4 stories deep, making sure that we can damp the cable motion and provide the maintenance necessary for these cables and to tune the cables so you can actually tighten these things up over time. And that will happen every year. I'll move quickly past that because I can feel Chris just behind me. And so I just have a couple of construction photos to finish off. These are the piling rigs that were creating the direct piles. These are enormous. They work 24/7, creating these enormous holes in the ground. And these are the series of barrette piles that we had to cut the top off of every one, all 145 in order to get them to the right finishing point, which was an enormous effort, as you can imagine. So with that, thanks for your attention. I hope you enjoyed that presentation.
John, no, it's interesting talk. Having lived in Saudi Arabia as an engineer, I'm not used to, but I can imagine the scope of some of these things. I've got a couple of questions. What do you mount the cranes on when you're up to the last 300 metres? The second question is, are there any inflammable panels on the outside of it? The third question is, what level on the Richter scale has the insurance company based the safety of this building? And I hope it all goes well, inshallah.
Thank you very much, inshallah. The gentleman has just used the Arabic term, God willing, inshallah, is the term God willing, which is used regularly for all things as simple as, I hope, my cup of tea is nice today, inshallah, to I hope this building won't fall down, inshallah. About craneage, there's a very long answer to that question. The two main methods, one involved actually running cranes up the outside, traditional cranes that actually go all the way up from ground. Where in the end we actually thought that was not possible to deliver. So we created a moving platform, so the cranes were mounted on a platform like an oil rig, and the platform was jacked up all the way to the top, along with many parts of that bud structure that was actually built down near the ground and jacked up. So as the concrete shaft went up, they jacked up, or they intend to jack up the bud structure with it. Richter scale, actually earthquake is not, it doesn't even really come into the consideration because the wind effects are so significant and are so significantly greater than earthquake effects. The earthquake issues fall away, although they do feel significant earthquakes that occur in Iran, across the Arabian Gulf, so that that's not unusual to feel actually earthquake effects, but they're not significant on a building like this. I think I might have forgotten your third question.
Oh, you've forgotten the inflammable
Oh,
materials on the outside.
no, there aren't any.
Yeah, that was excellent address, and having been to Dubai a couple of times and seen their architecture, this is definitely going to stand out. Two questions. One is, how long will it take to build? And probably find out how long do they think they'll take to build around this building. And then the other question probably relates to my experiences there, that I know you said you go to 1,000 metres, 900 metres, and it's a wonderful view. That doesn't always happen in Dubai because of poor visibility. So I'm just wondering if you want to comment a bit on both of those. Thank you.
Construction time is about 3.5 years, depending on the final methodology chosen, and in fact it depends mostly on the cranage option that is selected. So about 3.5 years. When I first started this project, the aspiration was to have the tower constructed in time for Expo 2020. You'll all be quite aware that that's not very far away now, and that aspiration was given up some time ago. So 3.5 years. The second time frame, I'm sorry. Oh, for the buildings around that will be a 15-year process, pretty much. Now, in terms of visibility, visibility is a major issue in all cities in the Middle East because of the dust and pollution. There will be days when you won't be able to see out of here, so you'll pay your $100 and you won't get a great view. Inshallah, the view will be clear.
That's all very mind-boggling, and just 2 weeks ago on Wednesday, I was at 148 stories on Burj Khalifa. You haven't said how many stories there's going to be. Would you just tell us?
It's a difficult question to answer, not because I'm not allowed to say it, but it doesn't have traditional stories. It's like a lollipop. It has no stories until you get to 900 metres. Then it has a roundabout, a 50-storey building on top. Then it has a spire on top of that. But a normal building of equivalent height would have up to 400 stories. If you translated it into traditional building forms.
Returns and guests on. Unfortunately, we are going to have to leave it there. Sorry, Peter and others. Adrian, thank you very much. It was absolutely fascinating. It was an absolutely fascinating talk. I knew it would be. And Rotarians and guests, can you imagine? Even those of you who not involved in engineering or construction at all, can you imagine what it would be like to have that building on your CV? Fantastic. Adrian, thank you very much.